Hello, everybody. How you doing?
Good.
All right, we still got a couple minutes.
Go.
You're not muted. You're not muted.
Guys, will be with you in just a second. I'm looking for a file that I just lost. Okay, that's what I was looking for. All right, I think we might only be missing one. All right, I think the gang is all here. I might be missing one, but we'll deal with that as we go. All right, how is everybody?
Great.
Oh wow.
Good. Ready to
Wow,
go.
this is enthusiastic. Oh my Lord. Okay. Yeah, I'm supposed to have 21 in the house, but that is not including me. So we are missing somebody today. Okay, so a couple of quick things. First thing I want to say is, I mean, I've already said that, you know, we're going to be here for 2 years. Ah, there we are. Okay. Last one is in. Okay. So I've already said before that we're going to be with each other for 2 years. And part of a class that's that long is getting to know you a little bit. And so what I would like to do is, okay, so just like, I know most of you guys are juniors. I don't know, I haven't even looked. Do I have any sophomores in the house? No sophomores in the house? Okay. All right. Under normal working conditions, there would be a classroom full of kids in my, in front of me, and I would see your faces and I would know your names. But the way it currently is sitting right now is that I'm looking at 21 black boxes. Thank you, Epps. Thank you, Emma. Thank you, Bennett. Now, I get it. You might have a very good reason not to share your screen, and that's fine. But love the background. Thank you. Very cool. All right. Getting to know you guys a little bit. And also the cool thing too is that, when I look out into the faces, I see, I either see the, or even the, the waving of hands, whatever. So, I mean, like being able to have a few people show me their screens, show me their faces, allows me to have at least an idea about what's going on in the room. Okay. So it's cool if you don't want to share your screen, but thank you to those that are willing to do it. Okay. Because think about it. What would it be if I taught the whole year like this? Think about that. Be like, okay, people, let's learn about infinite sequences and series today. So everyone take out your pencil and paper and write this down. Right. That would suck, wouldn't it? Yeah, that would suck. So yeah, you know what I mean? Okay, what I'm getting at. Okay, so first things first, let's get to work. First of all, did anyone, let me ask you this. Did anyone do that multiplication method or maybe that division method with somebody outside? Did anybody run to somebody and say like, check this out? Yeah, okay, I see a couple of heads moving. That's awesome. All right, cool. You know what? Who here has a younger sibling that's like maybe in middle school or something, or even elementary school? Does anybody have a younger sibling? Okay. Teach them that. Okay. I promise you, they will rock and roll through it. Okay. They'll just chew it up. Anyway, a lot of fun. Okay, so today what we're going to be doing, we're going to be on a topic, you actually covered it a little bit last year in Algebra 2 or Algebra 2 Trig, wherever you were. But we're going to take it, we're going to take it a little further. It's infinite sequences and series, okay? Well, not all infinite, some of them are finite. And before we go too far, what I want to talk about is some vocabulary, some language, some notation, and stuff like that. So let's get to work. Okay. Glasses help. Yay. All right. So first of all, let's talk about notation. A sequence, sequences and series. Okay, so a sequence is a list. It's separated by commas. And usually it's written in set notation, something like A, B, C. Okay, so by the way, notation about grouping symbols. Okay, before we go too far, these are braces. Okay, these are brackets. Obviously, you know what parentheses are. And believe it or not, these actually have a name. They are called brackets. These are oftentimes called square brackets. But if anybody's like going to go into physics, this, I know you're going to think I'm crazy, but I'm not. This is called a bra, and this is called a ket. I know, right? Mathematicians are really creative, right? But that's what they're called, a bracket. No kidding. It's ridiculous. And by the way, there is such a thing as this, and it's called a ket bra. I know, weird. Anyway, but sequences have commas in between them. Series are summations. So they have plus symbols in between them, and they sum up to something or not. Okay, a couple of things really quickly about notation. I know we all live in this world. We all know what this symbol is. It's an ellipsis. I always forget. Does it have one L or two? It's two, right? Is it one? Ellipsis? Okay, I know I can't spell. That's why I do math. There are two kinds of ellipses, 3 dots and 4 dots. Now, this one means if you see 3 dots, that means it is an infinitely long sequence. Okay? Or undetermined length. I should probably say that. Undetermined length. And the reason why I want to say undetermined is because it depends upon how it's being used. For example, I could say, I'm going to talk about all the even numbers between 2 and 100. Okay? So if I was doing that, I could say 2, 4, gosh, I'm good. Wow. 2, 4, 6. And you know what? I don't want to write them all out, right? So I'm just going to go dot, 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 comma, 98, 100, and I'm done. So in here, it's obviously not infinitely long, but it's just got, and when it's in between symbols, it just means I'm going. But if I said this, 2, 4, 6, dot, 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 at the end, that means it's going on forever. Okay? So it depends upon the context. Okay? Now, if I use 4 dots, this means it goes on and on and on and on, and then this last one stops it. This is finite. Okay? So if you see somebody doing this, that just means that they're enthusiastic. It does not mean anything, okay? And whenever you're writing anything, this is true also, okay? So when you see people saying blah, 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 you know, and then dot, 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 that just means that they really don't know how to write. That's really what it is. Okay. So anyway, we're going to be using these, so I just want you to know what I'm talking about when I write them. Okay. So let's talk about, we got 2 kinds of sequences that we're interested in, and we're also going to talk about their series as well. Okay, so first thing we've got arithmetic, and we have geometric. And we're going to be dealing with their sequences, and we're going to be talking about their series, and we're actually going to hit this topic now, but we're also going to come back to it next year as well. Okay, so really we're getting kind of like, you know, I'm going to give you just the hamburger with no sides for this year, and next year I'll fill in all the good stuff. All right, so in an arithmetic sequence, what I'm talking about is I'm dealing with a addition of a common term, of a common value or term. So for example, if I had 3, 13, 23, dot, dot, dot. Okay, so here I've got a common difference of 10. And we use the variable d often to say the common difference. All right. And in a geometric, it's very much the same thing, but instead of adding, we're multiplying. So here, let's just do, you know, something like 3, 6, 12, 24. Okay. So here, what's going on is I am multiplying by a common ratio. And that's given R. Okay, hopefully this isn't like completely and brand new to you, right? I mean, raise your hand if you saw this last year. I mean, even if you're like, dude, I saw that, I don't know what the heck is going on, but if this is not alien to you. Okay, the rest of you who have black screens, just give me a blue hands up kind of a thing. Or thumb. Okay. Couple people, maybe this is brand new, but we'll see. Okay. Now, the first term, depending upon what book you're using, is often given a variable of if it's an arithmetic, it's usually an A, and if it's a geometric, it's often a G. And notice the little tiny 0 at the bottom. That's the subscript. Let me zoom in a little bit. Is that better? Okay. Okay. Now, I want to talk about the notation of this before we go into like the math of it, so we know what we're saying when we see it. Okay, so let A naught, and by the way, that's pronounced that word naught is an old piece of vocabulary that pretty much nobody outside of the sciences uses anymore, unless you're like 90. And it basically is another way of saying 0. Okay. Has anyone ever seen the movie Shawshank Redemption? Like, I think everyone on the planet has seen the Shawshank Redemption, probably. There's a scene, oh my God, Bana, you have to watch Shawshank Redemption. I'm serious. Or at least read the book, okay? That was Stephen King. There's a line in there where he's talking, you know, the movie takes place in the 40s and 50s, and there's a scene where he's talking to a really, really, really old man, and he says, I came here in double naught, meaning he came there in 1900. 1900. Okay, so naught is another way of saying 0, but don't use it in that context. It's usually just a subscript. So let A naught equal 2, and let D equal 7. Okay, find A3. So this is an example of a simple arithmetic, and I know it's arithmetic because they told me that A and it's D. Otherwise, they would have to say, you know, if they're not using like the common vocabulary that we're used to. So here's what we do. We say, all right, my A naught, I'm gonna kind of like do this labeled out, like in kind of like a long form. But once you get comfortable with this, you won't have to do it like this. So A naught, A1, A2, and A3. So A naught was told to be 2. And A1 is made by taking this D and adding it to the guy before it. So add 7 and 2 and you get 9. I need to get to this location. So I'm going to add 7 again to get 16, and I'm going to add 7 again to get 23. Okay? Did everyone see how I kind of made that? I used the common difference, and I added it each and every time. Okay? All right. This is what is called an example of a recursive process. A recursive process or a recursive algorithm is well, first of all, an algorithm is a routine. Okay. If anyone here does anyone here know how to solve a Rubik's Cube? Emma, I see that head moving quick. Okay, how fast are you?
Like 2 or 3 minutes.
Okay, I've seen people like I'm a little faster than that, but I know guys that like I've had students do it in like 40 seconds, 30 seconds, 20 seconds. It's disgusting. The world record's like 5.32. It's nuts. Watch the videos; it'll blow your mind. And one of these days I'll solve it for you. Anyway, but okay, so when you do a Rubik's Cube, okay, this process, like for example, this is an algorithm. It's a process that you do over and over and over again. 1, 2, 3, 4, 5, 6, and there it is. Okay, that's an algorithm. Now, we write a recursive algorithm. A recursive algorithm always has the following pieces. It says what the first step is. And we said that one was, what would we say it was? It was 2? Okay, 2. Now, mathematicians don't like to write words if they can use symbols most of the time. So what we do is we have instructions. And we say that a to the n, so the nth, this is what this is, the nth term. By the way, who plays Scrabble? Okay, this is one of the only 2 words in the Scrabble dictionary that has 3 letters and no vowels. Okay, is a to the n minus 1 plus 7. Now, let's think about what the heck we just said. We said that to find a term, any term, it is equal to the term before it. Plus 7. Okay. Now, let me give you an example. Okay. Let me fix this a little bit. Okay. Sorry. Give me a second. I'm going to do this too. Okay. So if I was to tell you, and this is not an arithmetic sequence, okay, so I'm not going to use A, I'm going to use U, equals, let's do 2. U to the n equals 3 u to the n minus 1 squared. Okay, you're looking at me like, what the heck did he just do? Okay, so here's how it works. It says to me that I'm going to make a sequence, and it's going to be 2 is the first one. Now, so this is my 0th term. My first term would be u to the 1. Now, to get u to the 1, I take well, in this case, n is 1. So n minus 1 is 0. Take the term before it. That's what I mean. When you say n minus 1, you're saying the step before. Okay, the step I'm on equals 3 times the step before squared. So I'm going to take the step before me, which is 2, square it to make 4, and then multiply it by 3 to get 12. It's a formula, okay? It's what it's saying is use the thing before me to get me. Okay? Who here has ever played around in their calculator and like hit enter 100 times and the number just gets bigger and bigger, 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 or it gets really, 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 really small? We've all played with our calculators, people, right? You know what I'm talking about? Because what it's doing is it's using the step before it to give you the step in it. So let me, wherever the hell I put my calculator. Where the hell did I put my calculator? Oh, that's not good. Snap. Here it is. Here. Here's an example in the calculator doing the exact same thing I just talked about. My first step is 2. Now, I'm going to say 3 times my answer squared. Now, my next one, what's that going to be?
72.
3 times my answer squared. Wait, I have to square it.
$432.
Yep. Because I took 12, squared it, got 144, and then multiplied it by 3. And then it just gets crazy bigger after that. You see what I mean? Yeah, whatever. Giant. Okay, moving on. So this is the idea behind a recursive algorithm. In a recursive algorithm, let's do a couple. I'm going to have you do this one now. So this is an arithmetic, and you'll see it. Now, by the way, I use the giant brace to use it as a grouping symbol to say that these two things are the rules that work together. Okay? So what I want you to do is to find A4. And then privately put it in the chat box to me. Don't you dare pick up that calculator. Oh my Lord. Put that calculator away. What's my next term, everyone? I'm going to add 12 to it to get 17. And then add 12 to it again, 29. This is A0, A1, A2. Add 12 to it to get 41, and then add 12 to it to get 53. All right, good. Now, this is fine. Wait a second. I got Min, what's up? Min, do you have a question? Okay, your hand is up. That's why I wondered. Okay, I'm just gonna lower your hand. Okay, thank you. Okay, so this is fine and well, But if I had something, and I asked you if I had something like this, and I said, find the 4,763rd term, this would not be as much fun now, would it? Right? No, because you would have to do all of the steps before it in order to find out what the last one was. So a recursive formula kind of sucks unless you're doing it for only a handful of steps, okay? By the way, before we jump into the next step, there is a very famous recursive algorithm. It starts with this. Snap. This one's so famous it has its own name. So let's write it out. The very first element is 1. They give you that. The next element, which is A1, is also 1. Now, to find the next term, it says, do what? Somebody unmute and tell me what this says in words. Well, if this is the step I'm on, what does this say? What does this mean? We already mentioned it.
The
Is it
number
just the
before,
previous two terms?
The one
added
before.
together?
Yeah, the one before it plus,
the one before, the one before.
right.
This
So
is-
if I'm taking if I'm here, that's me. It's equal to the step before plus the step before that, which would be what?
2,
2,
What's this one then?
3,
3,
5,
5,
8.
8.
Does anyone know this sequence?
Yeah.
Fibonacci.
Fibonacci.
This is the Fibonacci sequence. The Fibonacci sequence is very famous. It's very useful. It pops up in nature everywhere, all the time. You can see this. You see this in the grocery store in your vegetables, for crying out loud. This pops. Yeah, I know. It pops up everywhere. Okay. And one of these days, we don't have Flex anymore, right? One of these days we'll go into it a little bit, or I'll throw some videos at you to watch about the Fibonacci sequence and where you find it. But this is a recursive formula for the Fibonacci sequence. All right, so recursive sequences are fine if all I have to do is find a couple of steps. But if I have to find a boatload of steps, it sucks. So what we do is we find what is called an explicit formula. An explicit formula is nice because all I have to do is plug in the number. So let's go back to the one that we had before. If I have, we had, the first term was 3, and then what do we do? Add 7 or something? We have 5. Yeah, 5, whoops. And then add 7 gives me 12, add 7 gives me 19. Now, here's the deal. If I wanted to get to this step, okay, how many of my D's do I have to add?
Just
3.
1, because it'd be 7.
Say that again? Well, no, like how many D's are used to make?
You'd have to add 3.
Yes. Okay.
Yeah.
So in order to get the third term, okay, well, in fact, this is actually the fourth term in the sequence, okay? And this is where kids get screwed up all the time. And it also depends upon what book you're using. Some places call this A1, and some places call this A0. I know, it sucks. It depends upon what you need, okay? Different books, different notations. Some places call this U, some places call this V. It just generally sucks. But to find, let's call this the fourth term, okay, I need to use 3 D's, right, added on to my first term. So let me ask you this question. If I was following this same process and I asked you for the 100th term, how many D's would be needed to make it?
99.
99.
Right. So here's the deal. To find, this is the explicit formula, okay? To find the nth term, okay, you start with your first term, and I'm going to use 1 here, okay? First term plus how many D's do I need?
99.
Right, but how did you get 99?
You take an minus 1.
Yeah, you take 1 less, because the very first step doesn't need 1, right? You only add D when you're going from step to step to step, right? So it's the value of D times n minus 1. Now this is not a subscript. This is a full-sized multiplier, okay? So let's use the example that we have up here. And then we just kind of clean it up a little bit. And that is your explicit looking formula. This is your explicit formula. Now, you know what? I'm going to make life, well, first of all, I'm going to unteach you something. Let's just make life easy and always start with A1. Okay? Just so that we're going to stick to one notation. Sometimes A0 pops up depending upon what book you use. I want you to know how to deal with it, okay? But no matter what, this is your formula. By the way, this is the first formula you're going to need in this class, and I'm going to write it down. And we're going to make a nice little grid of it. All right. So here are your formulas. The nth term of an arithmetic sequence is a to the n equals a1 d n minus 1. first major formula that you need in this class. Okay. Now, 1 second. All right, good. Hold this piece of paper aside. You're going to add to it throughout the day today. Okay? All right. Moving on. Now, if let's do an interesting problem. Let's say, where's my, I had some problems picked out for this. Okay. Okay. The 10th term an arithmetic sequence, because I'm lazy, is 61, and the 13th term is, what the hell was it? 79. Find the 20th term. Okay, this is the kind of question that you're going to be asked a lot. Now, basically what they're doing is they're giving you two pieces of data and asking you for a third. If we go back for a second, come up here, take a look at this formula. I do not know what the first term is. I do not know what my difference is. But I do know what n is because they gave it to me. They said that the 10th is 61. So n would be 10 in one example, and n would be 13 in the other. Okay, so what we're going to do is we're going to use this formula for each of these nuggets of information, and we're going to find all of our missing pieces because, as you'll see, it all falls out. Watch out. So the 10th term, so 61 is my first term, and my n is 10 minus 1. You guys see how I came up with that formula? Oh, sorry, how I came up with this information with this nugget right here? Okay. And I'm just going to go ahead and do some rearrangement right here, and I come up with 61 is equal to A1 plus 9D. Okay, so this is my first equation. Okay. Now, notice that I've got two unknowns, A1 and D. And in order for me to solve an equation of two unknowns, I need two pieces of information. Okay, two equations and two unknowns. Now, using my second little nugget of information, write down my next formula, please.
Mr. Ronco,
Yes, ma'am. What's up? Who's up?
could you go over how you got 61 for that
Because
one
it
part?
told me. It said the 10th term of the sequence is 61. So 61 is my value at that point. Think about it. This is A10, and 10th is n.
Okay, I got it. I got it.
So hopefully you got 79 is equal to A1, which we still don't know, D, which we still don't know, and 13 minus 1. So 79 is equal to A1 plus 12D. And this is my other equation. Show of hands, who got that for me? Okay. All right. So now I'm going to take my two equations and I'm going to rewrite them so that I have some room. So now what we basically have is just two equations and two unknowns. That's an A, not a 9. And we're solving it like we solved Algebra 1 systems, right? So my advice would be to use elimination to get rid of A1 and then find A1 and D. Min, is that a question or are you still raising your hand? Thank you. Once you find A1 and D, then go back to the original question and find me the 20th term by using that formula again. What did you guys get for D? You say it out loud if you want.
6.
What is it?
6.
6. So I'm going to subtract these two equations. Oh, sorry, -3. I gave myself my own answer. -3D, so D is equal to 6. Now you go back in, plug something in. And A1 is equal to what did you guys get? If you haven't finished, go ahead and finish.
Doesn't 9 times 6 equal 54?
Good. See, I can't multiply today either. People, Jesus. You know what it is that I'm teaching geometry right before your classes, and it's like I'm getting them to carry the frickin' 1. I'm sorry. Jesus. Wow. I'm good. Dang. All right, so what did you get? 7, I hope. Now, now plug it into the formula now that you know them both. So that's 120 minus 6, so that's 112, plus this gives me 119.
Uh, 6 times 19 is 114.
Right. Well, it's 120 it's 120 minus 6. Right?
Yeah,
Yeah, that's
and that's
100.
And then
114.
add
14.
7 gives me 121. Right. Again, because I can't freaking add. Guys, I'm serious. Like, how about this? You know, it's amazing. It's amazing the things that I screw up. I am always amazed by the things that I goof. You know, I do math all day long. And I just have like this great penchant for screwing up in front of people that can actually notice it. I suck. You guys know, I mean, okay, we're just about out of time too. I don't know, we got 12 minutes. Okay, good. One of these days I'll explain to you why I can't count past 3. Okay. Moving on. All right. Let's do this. We're not, you know what? We're probably, we don't have all this time in the world. All right. How about this? Here's a good one. The 8th term of an arithmetic sequence is 74. And the 15th is, what the hell was it? 137. Okay, so I think we know how to set up these two things right now, okay, based upon the last problem we just did. Now I'm going to ask you a different kind of question. So we're not asking for a certain term. We're giving you the term and we're asking you what index is it? You know, what position is it? When you get an answer, shoot it to me in the private chat. Everyone who's put it in so far, well, got a lot of right answers. I think what you did was you didn't finish it. Maybe, I'm not sure. Okay, let's do this one because we're almost done. So 74 is equal to A1, and I'm just, since we know it's 8 minus 1, it's 7D. Y'all okay with me taking that short, skipping that step? N minus 1, right? And 137 is A1 plus 14D. And you can subtract them or set for A, I really don't care. You get 7D is equal to 63. So D is equal to 9. And then plugging it into whatever you like, 74 is equal to A1 plus 63. A1 is equal to 11. Now that we have the two nuggets of information, we use the formula again. Right. Okay. Yeah, there are different ways of doing this one too. All right. So if I know that 227 is what I'm looking for, that is 11 plus, my difference was 9, n minus 1. So 11 plus 9n minus 9, 2 plus 9n. And then dividing it, divide it however you like, you wind up with 25. Okay. How does that feel? Impossible? Cindy, you don't look enthusiastic. All right. Okay, so let's do this. All right, let's do this. I want to give you a better set of problems than the one I just got you. We haven't done that one. We haven't done that one yet. Okay. All right, does everyone know how to take a screenshot on their computer? Good, I'm glad everyone said yes. This is what I want. I want this problem, number 4. Oh, I'm not screen sharing, am I? Okay, let's do this. I want that problem. Please take that screenshot. And then I'm going to give you a couple more on the other page. Okay. Everyone got that screenshot, yes?
No.
Give me a thumbs up or a hand raise if you've got it, that one problem ready. And then the next part of your assignment is 6, 7, and 8. So you have 4 problems to do. Okay, now here's one thing I want to point out. You'll notice that on the problem, the first picture that you took and this one that you took, they say 5 marks, 5 marks, 8 marks. Okay. What the marks are all about are, first of all, has everyone got all the pictures yet? If not, this is why we have group chat. Okay, cool. All right, the way this works, ladies and gentlemen, is that these are problems that are either exactly out of an IB exam or an SL exam, HL or SL, depends on where I stole them, or they are very much in the style of an IB problem. Now, we'll go more into this later, but basically, when you do this problem, first of all, like picking the right formula, plugging the right values in the right places, like doing certain milestones of the problem earn you points, okay? And if you complete all the way through the problem, then you'll have all of your points. But the point is, pardon the pun, that even if you screw it up, you could still be getting points out of it. The answer is not the number at the bottom of the page. That's not it. It's the process, okay? So dive into it, get as far as you can. If you run into headache, email me, okay? This is why I have office hours. I would like this back on Monday when we meet again, okay? I would like it if you could do this. You know what? Let's all try this. Take photos of your homework on paper. Send me those photos. Make sure that they're reasonably sized and that they're not like icons. Like I can't really read an icon. So like make sure that it's big enough that I can actually see it. If you want to paste it into a PDF or paste it into a Word document, that's fine, okay? But make sure that the file name has your name in it and that it says block 6, because I'm learning your names, but not all of them yet. And you know, with 180 kids, 150 kids, it's a pain in the ass. That was, so I need your name, I need your block, and just put in there first homework, okay? And then email me the image of your work. And if you want, remember, well, first of all, your work should be clean. And that's what I'm saying. It should be on blank paper and it needs to be in pencil, okay? Take pictures and email them to me. Or take pictures, drop them into a Word document and email them to me, okay? Are we good? All right, it is 2:30, the bell has rung, the buses are here. Merry Christmas, have a great day. Oh, and you know what? We had a fire drill today. Did anybody leave their house during the fire drill? Yeah, some classes actually did. Yeah, we had a fire drill today, like an hour and a half ago. All right, Merry Christmas, everybody. Have a great day. Bye-bye.
Thank you.
Yeah.
Thanks, Bronco.
Thank you.
Thank you.